Let us go through the Newton's laws of motion. So in this lesson, we're going to discuss a number of things, and I'm going to simplify them as much as possible. I'll be teaching as if I'm teaching a baby. Yeah, so by the end of the lesson, you are going to be smiling just like this guy here. Okay, so let's get started. We'll start with the first law of motion. So on the Newton's first law of motion, here this is where Newton was just trying to think of some crazy stuff. He said if an object is not moving, it will not move. Like, who doesn't know? So but that's the first law. If you have a box, you put it on a table, it will not move until an external force is applied. Yeah, so this is well known. So unless if wind blows the box, that's when it will move, or if someone just takes it away, that's the only point at which it can move. Yeah, that's the first law of motion. It states that an object will continue being at rest unless an external force is applied. And then now there's another version where we have something moving. Let's say we have a ball, it is rolling. So according to Newton's first law of motion, it states that if something is moving with constant speed, it will continue moving at that speed. It will never stop moving until an external force is applied. So like this ball, it will continue moving until maybe it hits a wall. That's when it will stop moving. Yeah, so but in reality, when you roll down a ball, it will not go forever. It will stop at some point. The reason is because on the floor there's resistance. So this resistance, it is an external force. Yeah, meaning we have an external force which is being applied. So that was Newton's first law of motion. Yeah, so it's pretty easy, and just like that, we're done with rule number 1. So now let's go to the second law of motion, where things now get more interesting. So law number 2. This is where we now talk about some physical quantities. The law states that acceleration is directly proportional to the summation of the forces and inversely proportional to the mass. So this simply means that acceleration is directly proportional to the force. If the acceleration is maybe, let's say 2, and then the force is 5. If you increase the acceleration, maybe you say it is 3, the force can go to 8. If the acceleration becomes 4, the force goes up to 11. You can see they are increasing at the same time. If one thing is increasing, the other thing will also increase. Yeah, so these are just random numbers. Yeah, and then for the mass, it is opposite. If acceleration is increasing in mass, then the magnitude of the mass is expected to go down. And if mass is increasing, acceleration should go down. And this makes a lot of sense. Let's say you have a small ball and you have a large ball. So you can see if the mass is being increased, it means acceleration will go down. Yeah, if you have a large ball, it means acceleration for this will go down. It won't move faster. Yeah, so that's the second law of motion. So now at this point, you're even ready for an example. Let us go through something that we can solve. Okay, so there is our first example. So remember, I said we're going to have a number of practice questions. Yeah, so stick around. By the time we'll be done, you have ideas on how to solve a number of things. So here we have an airboat with a mass of this, including the passenger, has an engine which is pushing it with that force. So after accounting for the force of resistance, find the acceleration of the airboat. So at this point, when you just analyze what we have been given, we can just remember Newton's second law of motion, which says that acceleration is directly proportional to the summation of the forces. So I'm going to explain on the summation when we're done with the example, with this example. So acceleration is equal to the summation of the forces over the mass. So what forces do we have? We only have one force. So 3.5 times 10 power 2 over our mass. So our force is 7.7. 7.7 times 10 power 2. That's our force, and then mass is 3.5 times 10 power 2. Yeah, so and then at that point you can go on, you punch that in your calculator. You are going to get around 2.2 meters per second squared. Yeah, so that's how we can apply the second law of motion. Yeah, and then before we jump to the third law, I would like to explain on the summation of forces. Yeah, so remember, I'm going to teach you like babies, so everything will be discussed in detail but very easy to understand. Yeah, so let's quickly do this. The summation, it simply means the addition of forces. So now you have to know how to add forces when you are given different kinds of problems. Okay, so let us say we have a box. Before that, again, we can quickly talk about the coordinate system. So you already know the Cartesian plane. So on the coordinate system, values which go above in the positive y-axis, we give them to be positive, and then those which go down are negative. For the x, when things are going to the right, we give them a positive, and then to the left it's a negative. You can also swap these if you just want to experiment out different kinds of ways of understanding physics. Yeah, so if you want, you can say positive should be this side, negative should be this side. If you are just consistent, then answers will be the same. So now what I want to explain here is how to add forces. Let's say you have a box like this, and then we have a force which is pushing it to the right. We're calling it force 1, but there is some friction force which is pulling the object. We're going to call it force 2. So now how you add the forces, you're going to say for the things which are going to the right, you should give them a positive. Yeah, so you're going to say this will be force 1 plus force 2. It is going to the left hand side, meaning it should be minus. Yeah, so meaning we have force 1 positive and negative, it is negative. So force 1 minus force 2. That's how you sum the forces. So these are called forces in the x-axis. Yeah, this is the x-axis. Yeah, that's how you add forces. Yeah, so remember, whenever you get to be stuck in any of my videos, you can just screenshot and you just reach out. like, okay, can you explain again? We'll go through it. So now it's very important for you to know how to sum the forces. So now let's say we have a force which is going up. Well, this is force 6, and then we have a force which is coming down. Let us call it force 4. So how you add? You're just going to say force 6, it is positive, minus, since this one is going down, under I've put minus, force 4. Yeah, so ahead you are going to have different forces. Yeah, so we'll be subtracting or adding where it is necessary. Okay, so that's how you go about the forces. I hope it's clear. And then one last part. When you're adding forces, we need to equate them to something. We have to equate them to something. So this is summation of forces in the y. So this is the y-axis. So always know that when we're adding the forces, we equate them to 0 if the force is not moving. But if the force is moving, we'll be saying equal to ma, because there's a force. Yeah, so let me just give you this example so that we're good to go. So let's say you have a force. This force, they have told you that it is going to the right hand side. It is being put to the right hand side by a force called force 3. And then maybe there's friction going in the opposite direction. So friction, we're going to talk about it later. We'll talk about it in more detail. Yeah, so if there's motion, if there's movement, and we want to add, we're going to say summation of forces in the x. Remember, this is the x-axis. So you write force 3, it is positive, minus force 5, which is here. So you equate this to ma, because they have said it is moving. If it is not moving, we equate to 0. Yeah, so write that in your book. So that was on Newton's second law of motion. Yeah, so at this point now, you are ready for the third law. So now things are now getting more interesting. Let us go to the third law of motion. So the third law of motion is quite funny. I don't know what Newton was thinking. So Newton said that when you slap a wall, let's say you slap a wall with a force of 5 newtons, the wall will also slap you back with 5 newtons as well. Yeah, that's the third law of Newton. It is like the law of revenge, maybe. Yeah, so if you hit something with a particular force, you also get back the same force. So now, speaking in physics language, what does this mean? So the third law of motion just states that, yeah, so let me just even write it down and then we talk about it. So this is the third law of motion, which states that the force exerted by object 1, meaning you, when you hit on another object, object 2, it will be equal in magnitude but opposite direction to the force which is exerted by object 2 hitting object 1. Yeah, so what this means is that if you hit, if we have one object and another object, if this object hits the other one with a force of 10 newtons, then the friend will hit the other one with an equal magnitude at 10 newtons, but in the opposite direction, meaning it should be negative. Yeah, so when you slap a wall with 5 newton force, it will also slap you back with 5 newtons. That is what Uncle Newton said. Yeah, so that's the third law of motion. Yeah, so you see, it's pretty easy. We're almost there. So we're done with the third law of motion. So we're just taking things step by step. By the time we'll be done, you'll be able to solve interesting questions. So now let's go to the next part, which is the normal force. It comes from the third law. Okay, so the third law of motion and how it relates to the normal. Oh, and sorry, I'm having a bad cough, but I just want to teach something. So the third law of motion, it is where we have how can we put it? Yeah, so let's say we have a book here. You have a book on a table. So you know that now we have a force of gravity, which is weight. Yeah, so the force of weight can be written as W, or you can write F like that, or you just put F. Yeah, this is the weight, and you should know weight is equal to mg. Yeah, so there's always a pulling force downwards. That is the force of gravity. We call it mg. So now, according to physics, these crazy physicists, they said even if you put a book on a table, according to physics, the book should sink. It should go deep into the table. The book should just be going down just like that. But why doesn't the book sink? The book doesn't sink down because we have an invisible force from heaven, which is called the normal force. Yeah, so this is just like the way life it is. You have people pulling you down, but there are people above who are pulling you. Yeah, so don't give in to negativity. You are going to pass. So now, this is called the normal force. It is the force which is perpendicular to the object. Yeah, so of gravity, it is pulling you down, but you have motivation still keeping you going. You have that discipline. Yeah, that's the normal. So now, yeah, so this is about the normal. We're done with the normal force. But physics should not be so, it can't be so easy. Yeah, so let us add a little bit of more detail so that we make it even more sweet. Yeah, so don't worry, it's all simple. These are baby stuff. So we have the normal force, and then we now come back to summing the forces. So if I were to ask you to sum the forces here, how can you do it? You are simply going to say, if something is going up, positive. If something is going down, negative. That's what we agreed. So when we add the forces, we're going to have N minus mg, because mg it is going down, and then we equate it to, we can either equate it to ma or we equate it to 0. So remind yourself, when do we equate to ma and when do we equate to 0? Yeah, so always remember, study this. So we're going to equate it to 0 in this case, because the object is not moving. If it was moving up or going down, we could have put ma to show that there's a force. Yeah, so this is how you add forces. So now let me even give you some work. Should I give you, okay. Yeah, so just try this work to check your understanding. Yeah, so let's say we have a box. This box, it is moving to the right. It is moving to the right, and then we have a force pushing it, we're calling it force 1, and then we also have some friction, we're calling it force 2, and then we also have an addition of force. It is not big, but there's another force. This is force 3. Can you sum the forces? Yeah, so drop your answers in the comment section. Let's see how you're thinking. For those of you who are introverts, you can reach out on WhatsApp. I usually take time to respond. I would be held up and all that. Yeah, so but when you have questions, just let me know. Yeah, so do this exercise. Find the summation of forces in the X. Yeah. So that is on the third law of motion. Yeah, so digest all this. It's very important. So now at this point, you are even ready for a very interesting example. I hope it's clear. So we have this situation here: a box with a mass of 10 kg being attached to a it is being attached to this horizontal cord. Okay, and then the force is 40 newtons at an angle of 30 degrees. Question A, find the acceleration of the box. So here, want to find the acceleration of the box, so you can draw a free body diagram. So a free body diagram, it is where we just ignore too much, where we ignore objects. Yeah, so let me just give you this example. Remember, here we teach like we're teaching babies. Yeah, so I explain very slow and I take my time. So just follow me well. So if let's say this is a car, it is moving with a force of 50 newtons. You don't really have to be drawing, you don't need to be drawing a car as well when you're solving. Like you want to show the forces. What you can do, you just put a dot and then you show 50 and we have mass going down, or weight rather, weight or gravity. Yeah, so this is a free body diagram. Instead of you drawing a car, you just put a dot. Yeah, or you can just put a small box to show that this is my car. So that's what we're doing here. This whole box, we can just write it as a dot. So what do we have? We have a force which is going up like that. This is 40 and it is on an angle of 30 degrees. So remember, objects should always have a force of gravity. Yeah, so meaning we have a force of gravity coming down. Okay, and then when you're dealing with forces, always know that you need the y components and the x components. Yeah, you always need those. So in this case, this 40 newtons, it is having y component because it is going up, and then it is also going to the right, meaning it has an x component. So you remember in vectors, we can find the x component. So what is the x component? What is the y component? Yeah, so our x component, always remember, from vectors we learned it will be r cos theta or f cos theta. So in this case, you just say 40 cos theta, which is our theta. So the answer is 34 38.6. That is our x component, meaning in the x-axis we have a 34.6. And then now what about in the y-axis? Yeah, so now the y-axis you can write it anywhere, here or there. It is just the y-axis. Okay, so let us write what is the y component. Remember, it will just be f sine theta. So our f, it is already given, it's here 40. So what is 40 sine 30? You get a 20. So our y component, it is 20 here. So this is mg, the mass. So now let us calculate the acceleration. So and then we can just put dotted lines so that we have a Cartesian plane which is looking complete. So they want us to find the acceleration. And how you know the acceleration? Remember, I told you when we are summing components, we can say equal to 0 or we can say equal to ma. You put ma when there's movement. So in this case, we're going to say we're going to collect the x components because that's where we have movement. In the y, in this case, we're not going to go for that one. Okay, so now the reason we're not going to go for the y component is because we've collected for the x to have mass times acceleration. So let us collect the forces in the x. So if there was any force here, we could have given it a negative. Yeah, you follow that. For example, in the y component, yeah, so I just have to make sure you have understood. In the y component, if we are to collect the components, we're going to say this will be positive 20 because it's going up, minus mg, minus because mg is going down. Okay, so here 34, it is going to the right, it's positive 34.6. And then we don't have anything else to add. Here we have nothing. So this is equal to ma. Yeah, so this is equal to ma to show that we have movement. If it wasn't moving, then we can just ignore. So over m over m. Remember, our m is 10. 10 kg there. So a will be 3.46 meters per second squared. Okay, so that's how you go about that. We can go to the next question. So what do we have? They want us to find the magnitude of the upward normal force. Okay, so this is interesting. They want us to find the normal. Oh, I was even forgetting that we have the normal. So let us find the upward normal force. We're going to say summation of the forces in the y. What are the things in the y? So here we have the y component. You can see it is already 20, y component. But we also have n. Yeah, so here on the box there's a force n which is making the box not to sink. Yeah, so we have n will be positive because it's pointing upwards. N plus the x component, which is 20, or if you want you can just kind of write a formula, or the y component. So n plus the y component plus what else is in the y axis? We have this gravity mg. So anything pointing downwards should be negative. So these things will be equal to 0. Is it? Yeah, so we can equate them to 0. This is to mean that there's no net movement in the y-axis. So n, we're trying to find n plus 20. The y component is 20. This is equal to mg. So we're going to have n is equal to mg minus 20. So m, it is 10. Gravity, it's 9.8 minus 20. And then from there, what is remaining is just to finish up. So 10 times 9.8, it is 98 minus 20. You get 78 there. So that's how you find the magnitude of the upward force. Yeah, so this was worth 3 marks. You put newtons there. So just understand adding the components. So in this example, remember, we already have n, it comes from heaven, but we also had a y component. Yeah, so these two were positives, and then gravity was a negative. Okay, so that's how you go about that. So we're almost done with the lesson. We're now going to discuss the other part about the normal force. What should you know about the normal force? And then we'll go to kinetic friction, static friction. So now at this point, I want you to understand how to add forces. Yeah, so the normal force, it can be, you can be given different scenarios. Yeah, so these are the general things which are out there. So the first one, a normal force on a level surface. We have actually already talked about this one. So this is a level surface, and then you have weight down here. Weight is mg. So always remember, we have a force from above. So in case you ever feel like no, physics is hard, just know that the angels are they are rooting for you that you will be okay. So the normal force there from above. So now how you add the forces. So we say summation of forces in the y. This is the y-axis. So we're going to say the normal positive, gravity will be negative, like that. So since there's no movement, we say this is equal to 0. Yeah, and then you can even make normal to be the subject, like that. So that's how you go about that one. So we're done with the first type. So now let us go to the other scenario. So what if we have a force, it is on a level surface but with an applied force. Yeah, so let's say we have an object here like that, but we have an applied force. This is like what we are just doing. We have an applied force like that, meaning we have an angle like that. So they'll just tell you that the force was applied at 40 degrees or any degrees. So how do you find the components? How do you add the forces? So always know that we have a force from above, and then we also have a downward force, which is mg. And then since we have an angle, it means you have to resolve this angle into the y component, meaning you have a y component. Yeah, so when you add the forces, so in some other separate videos we're going to have some practice questions. So now adding the forces, we're going to say normal plus, so remember the y component, it is r sine theta. So in this case we're dealing with forces, we say f sine theta. If you want to find the x component, you know it is cos. Yeah, so normal plus the y component, and then what else is in the y-axis? mg. Mg was going down, it's a negative, so this will be equal to 0 if there's no movement. If there's movement, you say equal to mass times acceleration. Yeah, so this is similar to what we are doing. At that point I just put y component, so you can do that. So physics is just more about analyzing. You get the general concept, what they want you to know. So maybe a force can be applied like this, you still have your angle like that. Yeah, so and then remember you have the normal, and then you resolve the y component. Yeah, so the summation of forces in the y will still be normal plus force sine theta, because it's in the y-axis. Yeah, force sine theta minus mg. Mg will usually always point downwards. Okay, and then now this other one, which is very interesting, this is where you would see questions coming. A normal force on a level under acceleration. So you can be given, maybe they tell you that something is in an elevator. They tell you that a book is in an elevator. So you know that the elevator is moving. So always know, firstly, we have a force of gravity and we have the normal, like that. So when adding the forces, we say forces in the y, normal should be positive because it's up, and then gravity negative. So this is equal to ma because there is movement. Yeah, so it is equal to mass times acceleration. Oh. And then finally the last part. The last part is where you have to understand, and this is where now majority of questions will be based on. Yeah, so we can even answer one question, which is having an inclined plane. So when we have a force on a slope, so always know the normal is perpendicular to the object. Yeah, so the normal is pointing like that. Yeah, so this is our normal. It is perpendicular to the object, meaning it is straight to the object. Yeah, not like this. So this is the normal force. And then the force of gravity, for inclined planes, you know, gravity will just go downward straight, but we have an angle. We can say maybe the angle is 40. So we have to resolve this mg in two components. Yeah, so we're going to have a force going direct straight, and then a force coming down. So at this point, this 40, it is the same with the 40 which is there. Yeah. So and then under vectors we said the component which is cut by the angle, we can give it a cos. Yeah, so this is mg, it will be cos theta. So meaning the other thing automatically becomes sin theta. Yeah, so now if we want to add the forces, remember the normal is pointing upwards. So summation of forces in the y, the normal positive minus this mg, it is negative, it is pointing downwards. So mg sin theta, because we resolved into components. Mg sin theta. So here maybe there's movement. Yeah, it's going down, there's movement. We put MA. Yeah, so these are the different scenarios. Yeah, so the questions which are ahead, I'll be reminding you like, oh, okay, remember those cases which we had. Yeah, so this is what you should now know about the normal. Yeah, that's all about the normal. So now let's quickly rush to kinetic friction. So here I'm just going to explain it right here. Kinetic friction, this is the opposing friction to the normal force. Yeah, the opposing force to the flow of motion. So let's say if you have a block which is going to the right, there's going to be some resistance pulling it. So this is the reason why even if you get a marble, or you get a tennis ball, or just get a regular ball, if you roll it, it will keep rolling, but it will stop at some point because down there's resistance. Yeah, so this resistance, it is friction. It is the one which makes objects not to keep on going and going. Yeah, so that friction, we call it a friction force. We write it like this, friction force. So this is the normal force which is pushing something, but we have an opposing force. So the opposing force will always give it a negative when we're summing the forces. Yeah, so in this case now, if we want to add the forces in the x-axis, forces in the x, we're going to say, okay, this is our pushing force, and then minus the friction force. Yeah, so the friction force, it is negative, and you can just remember from the coordinate system, something going to the right is positive, the opposite should be negative. Yeah, so F minus friction, it's equal to mass times acceleration in case there is movement. Yeah, and then remember I said something important like friction is always negative. Yeah, so sometimes if friction is here, we'll still give it a negative because it is opposing the usual force. Yeah, so this is on the kinetic friction force. And then there's a formula for kinetic friction, which is friction is equal to mu times the normal. Mu times normal. Yeah, this is the formula. So now friction is divided into two parts. We have kinetic and static. Kinetic friction is when something is moving, and then static friction is maybe, let's say you have a bucket, the bucket is just stationary where it is, and then you hit a ball and then the bucket does not fall over. Maybe it tops over but it comes back to its resting position. It means there's static friction. There's an opposing friction. You want to push it, it moves a little bit but it goes back. that is static friction. Yeah, something is constant. So the static friction, it is given by F and the small letter s is equal to mu small letter s times n. And then for kinetic friction, you just put k. Yeah, so this is on kinetic and static friction. So now that's all with this lesson. I've decided to pause just here. Ensure you internalize everything, the cases of the normal, understand all these things. Yeah, so in the next video we're going to answer questions like this one here, where we deal with the coefficient of kinetic friction. Yeah, so that mu, this is the coefficient of kinetic friction or static friction. Yeah, so we're going to go through this question together in the next video. Yeah, so otherwise keep on studying, and don't forget to subscribe. Oh, and you can let me know in the comments what video in physics would you love to see next time.